Of all the countless enigmas the universe has presented us with, this moment of deafening silence, is perhaps the most chilling. Because when science meets silence in the void of space, it's not the absence of sound that unnerves us, but the suggestion that something is deliberately choosing not to be heard. Picture this: the James Webb Space Telescope, humanity's most advanced eye on the cosmos, is suspended a million miles from Earth, adrift in the cold darkness, scanning space that most astronomers long considered to be little more than emptiness, a blind spot between galactic formations, too devoid of matter to yield anything but quiet data. And yet, that very emptiness just blinked back. The void itself moved. It didn't start with fireworks or gamma bursts, or the violent signature of a dying star tearing itself apart. No. What drew the eyes of the scientific world was nothing more than the absence of all expected readings. Like staring into a dark alley and realizing, slowly, that the shadows are staring back. The sector in question was near the infamous Erodana supervoid, a vast and eerie pocket of space where the density of galaxies is so low it almost defies standard cosmological models. This region has always been something of a riddle, but until now, it was an idle one, no different from the strange gaps you might find in a puzzle that's missing too many pieces. But on a routine deep field scan meant to calibrate infrared sensors for a new galaxy mapping initiative, the James Webb Telescope saw something it wasn't supposed to. Not a galaxy, not a star, not even the soft fuzz of distant cosmic dust. It detected what could only be described as a hole in reality. A perfect circle, pitch black, sharper than any planetary disk and more symmetrical than even artificial satellites. But this wasn't merely darkness. This wasn't just the absence of light, it was the annihilation of it. Unlike a black hole, it exhibited no gravitational lensing, no bending of light around its perimeter. No X-rays. No radiation signature. Just stillness. As if something had erased that part of the universe with a scalpel rather than a hammer. And then, as scientists puzzled over the data, something impossible began to happen. The edges of that silence started to pulse. Slowly. Not in random vibrations like a quasar blinking or a rotating neutron star giving off regular flashes. These pulses weren't light. They weren't sound. They were distortions, ripples in the spacetime fabric itself. And they followed a pattern. Prime numbers. First 2, then 3, then 5, 7, 11. As if this thing, this silence, was trying to communicate in the most universal language of all, mathematics. It was the kind of discovery that makes people stand up from their desks, abandon their coffee, and stare at the data in disbelief. Not because it defied theory, but because it mocked it. At first, there were whispers that it might be a new kind of black hole. Some exotic gravitational anomaly born from forces we hadn't yet modeled. But those theories collapsed when the mass calculations didn't line up. It had no gravity signature strong enough to warp nearby starlight. There was no accretion disk, no infalling matter. It wasn't pulling anything in. Instead, it seemed to be subtracting from the universe. A patch of sky not just dark, but disconnected. A tear in the operating system of the cosmos. As days passed, and the Webb team refined their instruments, the readings became even more unsettling. The region around the anomaly began showing interference patterns, tiny, barely detectable nudges in the telescope's most delicate sensors. Like someone tapping gently on the edges of the telescope's perception, checking if anyone was watching. The timing of those pulses became unnervingly regular, mimicking not only mathematical progression but mimicking intention. That's the word researchers started to use behind closed doors, intention. Because it wasn't just existing, it was reacting. And then, came the shift. Exactly 27 days after the initial detection, the object disappeared. Not like a star going behind a planet. Not like a satellite drifting out of frame. It blinked. Out of existence, and then, 0.004 degrees away, it blinked back in. A movement so subtle that it would have been missed if not for the incredible precision of Webb's gyroscopes and imaging software. But its implications were seismic. It hadn't moved through space, it had jumped. Teleported. Shifted dimensions. It didn't accelerate or decelerate. There was no in-between. It had simply ceased to be in one place and reappeared in another. This kind of behavior is unheard of in the macro scale. In quantum mechanics, entangled particles can react to each other instantaneously across vast distances. But those are particles, smaller than atoms. What Webb recorded was a structure the size of a moon behaving like a quantum ghost, obeying rules not of classical physics but of something far stranger. When researchers ran simulations of its reappearance pattern, a shape began to emerge, a spiral. Not just any spiral, but one with an inward trajectory. One pointing unmistakably toward Earth. It wasn't random. It wasn't a drift. It was directional. And it was approaching. By the fourth month of continuous analysis, the scientific community had moved from confusion to awe, and from awe to something closer to dread. The question was no longer, what is this thing, but rather, what does it want? Because now, the patterns around the anomaly were stabilizing. Fractal geometries were forming in its immediate vicinity, self-replicating across multiple wavelengths, and altering based on the telescope's angle and input. They weren't static. They evolved. They responded. Like a living system adjusting to observation. The comparisons became harder to ignore. These patterns didn't resemble galaxies or radiation fields or gravitational waves. They resembled neural maps. Brain patterns. Synaptic trees. Not like an animal's nervous system, but something more complex. Something recursive. It was as if, the more the telescope studied it, the more it studied us. Scientists proposed that this behavior mimicked cognitive adaptation, a system not built for observation, but for learning. And what made it worse, infinitely worse, was that it had stopped shifting locations. It had stabilized. Like a predator that had finished circling. And then, for one brief and breathless moment, James Webb caught something new. A subtle flicker on the outer rim of the anomaly. Not a shape, but the outline of movement. Something inside. Something changing. And then, a pattern appeared in the signal pulses. A new sequence. This time not prime numbers. But binary. Ones and zeros. Structured, repeating, building on itself in nested loops of code-like efficiency. Some researchers tried to interpret it. Most failed. But a group of cryptographers at a private lab noticed something horrifying. The pattern mirrored early packet structures used in Earth-based data transmission protocols, digital signatures eerily similar to those found in human-made code. Was it echoing our own communication systems back at us? Mimicking us? Responding to us? At this point, theories spun wildly out of control. Some believed it was a probe, an ancient intelligence from another universe slipping into ours through a dimensional weakness. Others thought it might be a remnant of an extinct alien civilization, still playing out its final loop of programming in the dead silence of the void. And still others whispered a darker theory, that this object wasn't from outside the universe, but from beneath it. An older strata of reality, something layered beneath spacetime itself, watching, waiting, and now, for the first time, acknowledging us. And the final nail in the coffin of normalcy came when the James Webb team, now working in tandem with other observatories worldwide, detected faint echoes of the same pulses in distant data archives, recordings taken years before Webb even launched. It had always been there. Watching. Masked by noise, hidden in blind spots, waiting for the moment we became smart enough to notice. And now that we have, it's getting closer. It began as nothing. Just a flicker in the background noise. When the James Webb Space Telescope tuned its instruments to study the deep silence between galaxies, it didn't expect anything out of the ordinary. Cosmic static, perhaps. A whisper from ancient stars. But what it found instead was rhythmic, repeating, impossibly structured. Not a star. Not a pulsar. Not a flare. It was a frequency. A beat. Faint and hidden beneath layers of radiation and interstellar interference, yet precise, as if calculated. As if sent. This pulse didn't belong to any known cosmic object. It wasn't gravitational waves echoing from colliding black holes. It wasn't a distortion in the microwave background. It didn't match the signature of neutron stars or the spin of a quasar. It stood alone. Singular. Puzzling. Some scientists gave it a name, the heartbeat beyond time. A poetic label for something so utterly alien. Others, more cautious, suggested it could be the vibration of exotic matter. The kind of material that shouldn't even exist in our universe, unless it came from outside it. But it was the pattern that truly unsettled them. Because the signal followed mathematical ratios. Golden spirals. Fibonacci sequences. Ratios used by artists and architects, by nature itself, to define beauty and structure. This wasn't noise. It was intentional. Designed. Encoded, almost like a transmission. But if it is a message, then who, or what, sent it? And while the heartbeat lingered in the background, the James Webb Telescope turned its gaze elsewhere. Toward the outskirts of the observable universe, where light is so stretched by time that it arrives as ghostly whispers. What Webb found there was more than stunning, it was disturbing. Light from faraway galaxies bent and twisted as if being pulled by immense gravity. But the source of that gravity was nowhere to be seen. There was no cluster. No black hole. No dark matter signature. Just space, empty, black, silent. Some researchers called these phantom gravitational fields. Others gave them more ominous names, mass shadows, void hands, invisible giants. The way they distorted the shape of space, it was as if something was pressing against the fabric of the cosmos from the outside. Not metaphorically. Physically. Pressing from another dimension, another reality, leaving fingerprints on our universe like condensation on glass. But what if it wasn't just pressing? What if it was touching, merging? The idea sounds like science fiction, but the math refuses to stay quiet. Some cosmologists now believe Webb has glimpsed the gravitational effects of another universe. A neighboring reality. A cosmic brain intersecting with ours. Theoretical physics has long predicted such interactions in higher dimensions. But never before have we had observational data that might confirm it. Webb is showing us something we were never supposed to see. A collision of realities that began before time itself. And we're only just noticing the ripples. Those ripples extend beyond gravity. They reach into the structure of matter. Because while analyzing particle spin and distribution in distant galaxies, Webb detected irregularities. Tiny asymmetries in the way atoms align. Patterns that mirror each other across impossible distances, as if reflected. But not mirrored from within our universe. Mirrored from without. Like the reflection on the back of a two-way glass. A universe made of the same rules, yet in reverse. This theory was once laughed out of academic journals. The idea of a mirror universe, flowing backward in time, with inverted laws of physics, was too wild, too untestable. But now it's finding new life. Because Webb's data points to cosmic structures that move counter to our expected models, spirals that twist the wrong way, jets that shouldn't exist, time signatures that defy entropy. What we're seeing might be the gravitational and quantum effects of a reverse-flowing twin, a universe entangled with our own, like two dancers spinning in opposite directions, bound by an invisible thread. And then came the echo. While observing light from the very edge of the cosmos, the last remnants of radiation from stars born only hundreds of millions of years after the Big Bang, Webb picked up a light signature it expected to lose. As the universe expands, such light should stretch and fade into darkness. But instead, it came back. Not from the same coordinates. Not from the same redshift. But with the exact same spectral identity. The same light. Returning. There are only two possibilities, and both are unsettling. Either space is curved so perfectly that ancient light can travel around the entire universe and return from the opposite side, implying that our cosmos is not infinite, but closed like a loop, or something caught the light and sent it back. Something reflective. Something vast. Something at the boundary of the known universe. But there shouldn't be anything there. There isn't supposed to be an edge. And yet, the light bounced. Scientists call this a cosmic echo, but that term masks its true mystery. Because echoes require surfaces. They require walls. And the universe, according to our models, has none. So what did the light touch? Was it the edge of time? Or the surface of another universe, waiting just beyond reach? Either way, the message is the same. Something is out there. Watching. Responding. The James Webb Space Telescope was never meant to find this. It was built to study the formation of stars, galaxies, and early cosmic structure. To help us understand how everything began. But instead, it's revealing how little we know. The galaxies it has captured shouldn't exist. The masses it has measured don't have sources. The light it follows bends in ways that defy gravity. The background noise of the universe is singing, and we don't know the language. Each discovery adds a layer to the unknown. The heartbeat. The phantom gravity. The mirrored structures. The echo. None of them, alone, prove anything beyond our universe. But together, they form a whisper, a suggestion, that everything we believe about existence might be incomplete. That there are corridors in reality we've never walked. That we are shadows on the wall of a much larger, much older room. One physicist described it like this: it's as if we've been staring at the painting of the cosmos, admiring its beauty, trying to understand its colors, only to realize now that it's just the surface of a sculpture. We've been looking at a flat image, when what surrounds us is three-dimensional, maybe even more. The most unsettling thought. That we are not just seeing another universe, but being seen by it. The echo returned. The heartbeat continues. What if something on the other side of reality is listening? Or worse, responding? The data from James Webb isn't just evidence. It's an invitation. An invitation to leave behind the comfortable boundaries of what we call reality. To accept that the universe is not a container, but a participant in something far greater. A system of systems. Realities within realities. Where time is only one of many dimensions, and space folds like paper in the wind. And yet, through all the mystery, one truth remains: we are not in control. We are observers, drifting inside a universe that may not be ours. We are travelers walking through a museum of creation, only now discovering the door was never locked, it was just slightly ajar. The James Webb Space Telescope didn't just change astronomy. It opened a wound in our understanding. A beautiful, terrifying wound through which truth may pour in, if we're brave enough to look. And now, the question is no longer whether life exists beyond the stars.